Welcome to our lesson on integration by parts. Today, we're going to evaluate the integral of x times sine of ln x dx using integration by parts twice. Here's the integral we're going to solve. The integral of x times sine of the natural log of x dx. Let's recall the formula for integration by parts. The integral of u dv equals u times v minus the integral of v du. We'll first choose how to break down our integral. In this case, we let u equal ln x, abbreviating dv as x sine of ln x dx. Differentiate u and integrate dv. This yields the following differential. Now differentiate u with respect to x and integrate dv. This yields du equals 1 over x dx, and v equals the negative cosine of ln x. Substitute these expressions into the integration by parts formula. This gives us the following. The integral of x sine of ln x dx equals negative x cosine of ln x plus the integral of cosine of ln x dx. Now, we haven't solved the entire problem, but we've simplified our original integral into another that can be solved using integration by parts again. Now, to evaluate the remaining integral, we'll apply integration by parts again. We let u equal ln x and dv equals cos ln x dx. Differentiating and integrating gives us the following. Du equals 1 over x dx, and v equals sine of ln x. Now, to evaluate the remaining integral, we'll apply integration by parts again. We let u equal ln x, and dv equals cos ln x dx. Differentiating and integrating gives us the following. Du equals 1 over x dx, and v equals sine of ln x. Now, we differentiate u and integrate dv. What do we get? Du equals 1 over x dx, and v equals sine of ln x. Substituting these into the integration by parts formula a second time gives us the original integral. The integral of x sine of ln x dx is negative x cos of ln x plus ln x sine of ln x minus the integral of sine of ln x dx. We're still left with another integral to evaluate, but notice something interesting. Our integral can be easily related back to itself. We'll leverage this, solve for the integral, and find its value. We rearrange it to yield a solution. The integral of x sine of ln x dx equals